last class we discussed something called Gini index. Anyone having any doubt or any problem calculating the Gini index, right? So the file which I has given, that is about the Bollywood movies when they are releasing, or like whether it is in a weekend. So that description was given, right? Whether it is a normal weekend or Hollywood weekend or extended weekend, right? So they want to predict how much revenue, how what is the like kind of whether it is a flop movie or a hit movie, right? So and there are different parameters, right? And that is where I have asked you to calculate the, and I think the only parameter I had given you on the when that movie is getting released. So N, I think Apurva Ranesa was asking about the N. N is nothing but the number of movies released, total number of movies released, and how it is defined, right? One or zero. And if you go through this slide, we have already discussed how to calculate Gini index of each node. So the idea is the Gini coefficient or index variable, by using whichever variable we are able to get a better kind of reduction in Gini index. We'll take that variable as our first variable of classification, right? If you remember, that is what we started our discussion, right? When we say that this is my root node homeowner to classify whether somebody will have a good credit worthiness, right? So what does it mean? Out of all these variables, ownership, home ownership is one variable categorical, one or zero. Marital status, again, single divorce, they have put it in one category, then married in another category. Annual income, which is a continuous variable, but they have divided into two groups: greater than $80,000 per annum, less than $80,000. So the idea is when a algorithm is building the model, on what basis it will take, okay, homeowner is the root node. That means it will start with homeowner. Right? It cannot be random because you will get different answers if you take randomly different nodes. Right? So the idea is whichever variable, whichever parameter or whichever factor has the most important value, right? And so how to define or how to decide which is the most important one? We discussed that, okay, there are three. So split criterion means on which basis you will make that split, right? Which basis will make that group. So chi-square Logworth, so that is log p value, which I'll show you. Then there is something called entropy, then there is something called Gini index, right? So Gini index, we have discussed how to calculate Gini index. I hope those groups who have done it correctly. It is basically simple calculation, right? So how the group is being classified, right? On which parameter it is getting classified, right? So here the formula will be whatever my parameter 3, I want to find out that percentage. 3 divided by 3 plus 4, 7. 1 minus 3 by 7 square, then 1 minus 4 by 7 square. Because here you will see when we are calculating Gini for this node, I have total how many counts? 12 count. One C1, which is my target variable, right? How many people, let's say, are credit worthy. So in the existing data set, I have 12 like kind of data points. 12 n is 12. Both are equally divided, 6 and 6, right? Where I have not put any variable to classify. So there are 6 people who are credit worthy and 6 people who are not credit worthy, whom I should not give my any credit card or any loan, right? So if you see here, your Gini index is 0.5, 1 minus 6 by 12 square, 6 by 12 square, right? 1 by 2 square, 1 by 4, 0.25, 0.25, right? Now if I put a criteria, let's say one criteria is home ownership, right? Then I find out my critical, whatever the kind of Gini index, right? So here I found out my Gini index for these two nodes. I take the weighted average. So overall reduction for this variable, if I create or if I take this variable is my split criterion, right? The overall Gini index for these two nodes is becoming 0.486. That means I'm able to reduce by only 0.014, not much. But if I'm taking some another variable, right? My overall Gini index is becoming 0.3715, where I am able to reduce your Gini coefficient by 0.1285, around 25%, right, from my original value. That is where I'll say that, okay, rather than taking A as my criteria, I'll take B as my criteria. Then again, A can be considered, right? Once, let's say, this classification happens, Now which variable to take? Let's say there are 4, 5, 6 variable A, B, C, D, E, F. So B is the first one. Then again, I'll decide between which is the next variable I should consider for my split criterion, right? So this is how you gradually build. Obviously, we are not doing manually. The model is automatically calculating and accordingly choosing that, okay, which variable it should consider for my first criterion, right? First split, then second split, and third split, right? Uh, Similar extent, there is something called entropy. Entropy, as you remember in physics, the chaos, right? Always world moves to like larger and like basically entropy increases always, chaos increases, right? Disorder increases. So the idea is if there is a messy data, if there is a, I am not able to find out differences between who are credit worthy, who are not credit worthy. Is there a way, is there a classification variable? Is there a factor or independent variable which I can use to bring some order? Obviously, it will be rarely possible to bring one variable which will clearly say that this is the credit worthy person, these are the not credit worthy persons, right? Anything. It can be related to any, like whether somebody has some disease or not, right? So that's why we use multiple variables. But the idea is in which order you will use those multiple variables. That is defined by either that minus log of chi-square value, chi-square p value, or your Gini index or your entropy, right? Similar calculation, only point or difference or problem, if I may say, here you have to use the log 2 value, right? There, if you see, it is a simple calculation, you can do it in a calculator or manually without calculator also you can do this calculation. Only problem is that when you are calculating entropy, you need some value of logarithm scale or logarithm table you might have to use, right? But similar kind of, if I just consider this root node A and I have created, let's say there are 7 people who are going to, like let's say in today's classic sense, will do something, who are willing to give something for children, right? In Children's Day, so they have agreed that okay, to those people, those children who are underprivileged, they do not have food to eat or clothes to wear. So there are, out of 12 people we contacted, 7 people have agreed. So we contacted 12 random people. 7 people have agreed. 5 people did not, said no. Right. So I have, let's say, taken a criteria which is not written here. Let's say taken a criteria. Let's say their income level. Right. So based on certain income level, I created, let's say, those people whose monthly income is greater than 50,000. So if I take, so this is right, sorry, right side, those people who are greater than 50,000. So out of those 6 people, 5 are saying yes, one is no. Those people who are earning less than 50,000 per month, out of that only 2 yes, 4 no, right? So the idea is if I take that as a variable, that income, monthly income as a variable, how much reduction in entropy is happening? So initially, if I do not have any other variable to classify, I have 12 random people whom I had asked. Out of that, 7 people have said yes, 5 people have said no. Then when I use another variable, or the first variable is, let's say, average monthly income. Those people who are like, let's say there are 6 people who are greater than 50,000 income, 6 people who have less than 50,000 income per month, right? So I get that, okay, out of those people who are, so this row, this line is for those people who are higher than 50,000 rupees income per month. Out of them, 5 have said yes, then one is, then again another one variable I have used to classify this, right? So here if you see, classification has become good. So whichever variable I used here, it is able to clearly classify this 5 yes and one no. So one category which is 5 yes, another category who is no, right? So but if I'm just taking these two nodes, same calculation what we did in index, as first I have to find out the what is the entropy in my original node, because in original node I do not have any other variable. So the formula is difference between, like, kind of, okay, first let me find out what is my kind of entropy of this node B, right? So the classification, so how many of them have said yes, because that is my target variable. How many percentage, how many people, how many like percentage of people have said yes? 2 by 6 out of 6 people. 2 by 6, logarithm of 2 divided by 2 plus 4, again that classification value, minus how many people have said no? 4 divided by 6. again logarithm 2 of, so if you go back to the formula, P minus PCI, that percentage of classification, whatever is my ES divided by ES plus no, ES divided by total number of people, then multiplied by logarithm 2 of base 2, same thing, probability of classification, right? Percentage of classification. So if I do this, so this is for point B, it is 0.92 bits, right? And entropy C is for node C is 0.65 bit, right? Again, I can use that. Okay, what is the entropy of this? ES is 7 by 7 plus 12 logarithm 2 of whatever 7 by 12, right? So now I'll find out that if original node has this much entropy, what is the weighted average of these two nodes? How much entropy we have reduced, right? Same example if I take again to do some calculation. Let's say I have 30 instances, right? 30 people, let's say, plus is means those people who are credit worthy, 0 or the green symbols are, they are not credit worthy, right? I use kind of any kind of variable, let's say their home ownership or income, that is not mentioned here. Here, what we are saying that how much entropy reduction is happening, right? So let's say I take that income as another parameter, $80,000 income above $80,000, right? So this group, 80,000 income dollars is this group. So there are 17 people out of 30 who are earning more than $80,000 per annum. 13 instances who are earning less than $80,000, right? So if I calculate the entropy of this, what are the positive instances? So this 0 green symbols are 4, right? So that means out of 17, 4 are no, 13 are yes, right? Probability of yes divided by total number of counts or total number of data points, 17 data points, 13 by 17 log 2 base 2, 13 by 17 minus probability of no, classification probability of no, that are 4 dots, 4 by 17 log 4 by 17 log base 2 4 by 17. So it is again 0.787. Similarly, I will calculate for this node also 0.391. I'll take the weighted average 17 multiplied by 0.787 plus 13 multiplied by 0.391 divided by 30. That will give me a value of 0.615, right? What was my original entropy, parent entropy? So out of 30, there are only 14 yes, right? And 16 no, right? So 14 by 30 log 14 by 30, 16 by 30 log 16 by 30. So entropy is close to 1. 1 means very high, right? So that is very huge disorder, right? Everything, like anytime you start, it will be very big disorder. We do not have any classification criteria. By using a classification criteria, and when I take this weighted average, the entropy is come down to 0.615. Like we did exactly for Gini index. What is the Gini index for the original node, parent node? What are the weighted average for child nodes, right? So how much disorder we have removed, right? 0.996 minus 0.615, that is 0.38. That means we have improved our information, because when we say classification has improved, that means information about those group have improved. Now I can go and say that, okay, there is something greater than 10,000 or $80,000 income is giving me a classification of 12 12 negatives and 1 positives. Less than 80,000 income is giving me 12 negatives and 1 positives. Similarly, 80,000 income, those people who are having 80,000 greater than $80,000 income, giving me 13 positive and 4 negatives, right? So I'm improving my information. I'm getting my more information, more data about my nodes, right? So that is known as information gain 0.38, or reduction in entropy, reduction in disorder, whichever we tell it. Idea is to reduce that disorder, reduce that chaos, right? Then how do you compare different models, right? Leap, which we have discussed in the previous class. If I'm building this model, ideally model should improve upon the random model. Random model means I do not have any model. Randomly, if I anytime this decision tree or logistics regression, it is always about the classification, right? I want to understand whether I'm able to classify into 2 or more groups correctly. right? Lift means how well my model works in comparison to the baseline model. Baseline model means if I do not have any model, if I just go by my intuition, right? In comparison to that, let's say that day, like in logistics regression, like we are discussing, if a marketing campaign has been run and we know that we have a success rate of 10%, that means out of 1 lakh customers whom we have contacted, average kind of callback has been 10%. 10% of customers have agreed to take some of our products or buy some of our product. So without building any model, this year also I can contact another 1 lakh or 5 lakh customers. I can spend certain money on advertisement, promotions, call centers, and all those things, and believe that my performance again will remain 10% because that is my baseline model without creating any prediction. So now the question, if I am using this much software, this much bandwidth, this much people, this much resources, whichever model I'm building, am I able to build a better model which can say that, okay, if you target this rather than targeting this 1 lakh, if you target this 20,000 or 50,000, your success rate will be 20% or 30%, right? From the baseline model. Baseline model, if I have contacted only 50,000 customers, my success rate only would have been 10%, right? If I say that, no, if you use my model, if you use my suggestion, target people having greater than $80,000 income, having a home, not married, then your success chance that person taking a credit card will become, let's say, 48% or 40%. Then what happens? My model is able to improve the baseline performance by 40% divided by 10%, that is by 4, right? My lift will become 4. My gain will become 40% divided by 10% minus 10%, 300%, right? So gain from the baseline model will become 300%, and my leap will become 4 times because the performance of my model is 4 times better than the baseline model. That is nothing but your leap. Misclassification that we have discussed, we try to remove or reduce type 1 error and type 2 error, false positives and false negatives, right? How many who are actually not our customers, we have classified that they will become our class customers, and how many of them are customers, and we have said that no, that person is not actually our customers, he is not a credit worthy person. Both the cases will try to reduce, right? Average square error, not necessarily in the classification it will be required whenever you have a continuous variable, right? How much, like in this particular case, there is a variable which says that how much gift they have given in the project which I have given, how much donation a person is going to give. So in that case, whichever donation you estimate from your model and how much actually he is giving, so that is the difference, average square error. Then decision, for each of the decision means, let's say whether I'll run a marketing campaign or not, whether I'll say that, okay, this is the credit limit above which I will provide that person a credit card. Below that, I'll not provide that person a credit card. All these are decisions, and decisions some of the times or most of the times will have certain weights assigned to it. If I, let's say, take a decision that, okay, I'll run a marketing campaign to these individuals, so that decision has a weight because I know that when I run a campaign to these 50,000 customers, per customers, if I spend 10 rupees, so I'm going to spend 5 lakh rupees for my advertisement, right? So that is a 10 rupees decision weight for each of those decision I'm making, right? Rather than those 50,000, if I increase that 1 lakh, so my increase in cost will become 1 lakh multiplied by 10 is 10 lakh, right? So that is the decision whether you are going to measure your model based on decision, that is also we can do. Then there is something called pruning options, like on what basis you will say that. So remember, tree can be like very messy also, right? So you'll get lot of leaves, lot of branches without any value addition to the model, without any value addition to the business. Pruning means you are cutting unnecessary branches, cutting unnecessary leaves, making it like agile, making it simpler or better, correct? So this anyhow I've discussed. I have already shared the slide also. So quickly let us go through the data and try to build model, and I'll show you what kind of different models you can build. then we'll go back and discuss in the slide. So first step, as you know, you have to go to the SAS Studio. I hope you have uploaded the data which I had given you today, right? So that is again a donation charity data. So the first step is always go to your, where's my SAS Studio? So I had uploaded this file PVA 97, which I have given in your classroom, Google Classroom, right? So always whenever we are running something in Enterprise Miner, right, we have to take the like kind of directory path from the SAS Studio, right? So click on the properties. So this is my property which I have been using from other classes also. I'll copy this. So whichever directory where you have put this file, right, you can copy that path. Then so let's say I keep today, this is entry 28 March. So I'm creating a new project. Okay. So I'll go to the program editor. So this is where we'll create a library, right? Late name. This is entry 28 March. Create data source as table, browse. So this is the file I'm going to use today, right? Same thing in the project also, whichever file I've given, right? Upload first in the SAS Studio data, create a library here. So the syntax for like creating a library is lib name. What is your library name? Give a library name, let's say project, pause project, or whichever name which you want to give. Then provide the link of the directory, path of the directory, semicolon. Next line is run, semicolon, right? So I'm going to use this file which I have uploaded earlier. Okay. So my internet has some issue, I guess. Okay, so it has been selected. Put next, click on advanced, click next. So if you just click on label, right? So in the earlier class exercise, I had given you the information about each variable, right? Here itself in the data file it is given. If you just click on the label, it will give you the some additional information about that variable, right? So scroll down to below. There are two variables which is already mentioned as target B and target D, right? So one variable is gift flag. That means whether that person has given some gift to children or whichever like old age people, right? How much, like whether he has given or not, whether he or she has given or not, right? So it is binary, right? Yes or no. Other variable is a gift amount, right? How much amount that person has given, right? So what we'll say, will out of this variable when I'm doing a classification, right? I'm interested in whether that person has given or not, right? But if I'm using it for a, let's say, predict that how much amount that person has given, I can use this as my dependent variable. But whenever I'm using to predict some classification, whether somebody is going to give something or not to children or not, right? So that is 1 or 0. That is a binary variable. So in my case, what we'll do, I'll keep this as my target B, other variable, which is of kind of continuous data, right? The kept amount data, right? So these I will reject from my model. Rejected means I'm not considering that for my model. Right? That is the only thing which you have to consider or which you have to use it for your model. Right? So same thing for your project also. In project also, it is similar kind of data file. It is for the charity. How much charity a person is going to give, that is a continuous data that you reject. Whether that going to person is going to donate or not, right? To charity, yes or no, that you keep it as target. Any questions up to this point? Sample data set I'm not going to create, we'll use data partition, right? So one additional step always we require here, copy this code, 2 lines of code, go to your project DT28 March, in the project start code. So this, I guess, whenever I fetch this project later on in future, it will always link to the directory path. I need not have to again create a library for this, right? So once you do that, you have a data source. Now we'll create a diagram. 28 March. So first, obviously, the first step is always to bring your file, bring the whichever data set to work on that. I track that. One additional step we'll do here. So we'll take something called replacement. This. So this basically we are doing if there are some outliers, right? We'll be able to remove that. Just a moment. So drag it to this. So here if you see if there are any unknown values are not given, it will be ignored, right? And interval variables, that is continuous variables, right? If standard deviations from mean, right? If multiple standard deviations mean some outliers like that will be also ignored, right? So these I can mention here cutoff values, right? So this is already automatically mentioned. Percentage for extreme percentage, modal center, standard deviation. So more than 3 standard deviation, if some points are lying, right? It will be automatically discarded from your model. So this is my initial data file. So I've created this replacement node. Let me run it. So if you see for certain variables, it has created certain new variable, right? Whenever it has a kind of a it is above or below certain control limit, right? So that step is done. So first step is basically, if you remember that SEMA architecture, right? Sample, then modify, SEMMA, right? Modify, then your model, test, sample, explore, modify, model, and assess, right? So up to now we have not assessed the models, right? Compare the models. Today we are going to do that. So we'll take a data partition. We'll bring this node, connect it. So again, it is up to you, but for your project point of view, I've just removed the validation data set. What I've done, take 50% training and 50% as your validation. Sorry, 50% as your test. Right. Data partition. That is the only thing we have to do. Then we'll partition the data. Okay, so these are the 3 steps, and directly I can go to this model, and there is something called, where is my decision tree? So here is decision tree. I can bring this decision tree, create a decision tree, right? But today, like I said, what is our objective is to create multiple different types of decision tree and compare that. And we also will create something called logistics request. So whenever you have this kind of option, right? Multiple models you have to run in a single data point, right? We create something called a control point. Click on the utility, right? So the first point which you have, that is something called control point, right? So it is basically to make sure that same data flow, same data, whatever you have created, training and testing data set you are using for multiple different models, right? So it will help you to create and compare different models. Otherwise, separately you have to create multiple decision trees, right? So this is control point. Now we'll go and create model. So model decision tree. Okay. So link this to decision tree and we'll rename this. So this is something which will create a full decision tree. I'll show you what is a full decision tree. Let me rename one full decision tree. Okay. So click on this, go to train, right? Left side train. Click on this interactive, right? So there is something called interactive. Just click on that. So what it says, this 4843, I have around 9,600 or 9,800 data set, right? It has divided into training and testing data set. Is this tree view, a new screen is visible to all of you?
Yes, sir.
Okay. So what it says, basically I have now 4,800. So it has divided equally, right? I have 9,400 or 500 data points. It has equally divided. So now we are going to build decision tree, right? So if you right click here and say that, okay, split node, right? Just click on this. So this is what I was discussing earlier. Sorry, chi-square, logarithm of chi-square p-value, right? So it has put a ranking order of your variables, right? In case you are building decision tree, right? Which variable is being taken as your gift amount average card, right? 36 month. What is the average gift amount in the card, whichever gift card they're using in the last 36 months? That variable has the largest log p value, minus log p value, and that will minus log p value largest means p value is smallest. So that means will be, so that p value is smallest means it has the most significant variable, we should consider. So here you can edit the rule also. If you see, if I go and edit the rule, then followed by gift count for 36 months, how many times they have gifted, then gift amount, last gift amount. So like that, there are different variables in order of ranking, right? So this is the most like important variable out of all the variables which was in the model. Okay, I can go and edit the rule also. So this is the $14 or whatever, $14.41, whichever currency they are using, right? So that is the split point, greater than $14.41. Your business might say that, okay, this is not a like value 14.41. When we use it for our production, it will be very clumsy to put in decimal point. So why don't you make it a whole number, right? So I can say that, okay, let's say new split point is 15, add branch, then this I can remove branch, right? Then I can put OK. So this is how for each variable, if you have a certain business criteria, no, you cannot consider 14.41 as a parameter, right? So that also you can do, right? So let me just put OK. So now, okay, I put OK. Then again, if I go and put a split node, right? So if you see the next variable which has come, which has a minus log p value of 6.44, median home value region. For that particular region, what is the wherever that customer is lying, what is the median value of that home? wherever that customer, like let's say if I comparing in India, obviously median value of home in Mumbai, Delhi, Bangalore will be much more higher than other cities, right? So that also has an impact. Right? So like that, I can keep doing one by one, or I can just say train node. So automatically what will happen? Let me give. So depending upon how I had created the node, how I have created the first node, second node has been created, third node, third level of nodes, fourth level of child nodes has been created. So this is where you can train a full decision tree without any restrictions, right? Are you able to create, or anybody having any doubt, any problem creating this interactive decision tree? So rather than going split node one by one, you can create a full decision node if you just click on the starting point and say that, okay, train node, right? So all the nodes one by one, it will be created for you. So if you see this 15 value, initially it was 14.41, that I have changed to 15, right? So those things also you can do. Any questions, any doubt on this?
So the training and testing data sets, sir, why have you taken 50% and 50% and not 70, 30 or 80, 20?
And you can take here for this one, you can take. So there is no problem there. Just a moment, my internet, yeah, it is working now. So for this question,
so you can switch off your video.
Yeah, I can do that also. So you can like kind of take here for this kind of exercise, you can take 60, 40, 70, 30 up to you. But for the project work, I've given you 50, 50. There is no like kind of justification for that. I just want to see that because I have a very kind of less number of data points. You should have a like at least for the classification stage, you should have enough data points to run these algorithms, right? So that is one reason where I have taken 50, 50. If you have like multiple, like let's say lakhs or millions of data points, even 20% of testing data set also will have a significant number of data points. So now for the class exercise which you are doing right now, you can do 60, 40, 70, 30. This is up to you. But for the project work, I have mentioned it is 50, 50, right? So this is our full decision tree. I hope everybody is able to create this. Then again, we'll drag another decision tree. So this one, which I'll do, I'll make some changes. I'll rename it and I'll say that pruning of tree. So what is the pruning? Like I said, pruning means you can define how big the tree will be, how many leaves it will have, right? So this is my second level of decision tree, which I'm calling it as a prune decision tree. Okay. So if I just click here, I'll go leaf size is 5. That means minimum, as long as in a child node you have a leaf which has 5 values, right? It will keep or it will start creating, right? But 5 is a very small number, having 5 customers in one node and which you want to explain, right? So depending upon your business objective, business manager might say that, okay, no, keep at least 100, 50 or 200, right? Up to that level only you create tree, right? So that has to come from your business, because otherwise what will happen? It creates different groups of 5, 10 customers. It becomes very difficult to create a rule for them, right? So these again, it should not come randomly that okay, how much leaf size. Let's say just for example today I'm keeping it 10, right? Maximum depth 6. How like labels of nodes will be created? How many labels of variables will be taken? It has taken as 6. I can take maybe little bit more depth. I can keep it 10 or 8, right? Again, this has to be like see, because what happens if you, as long as you're creating a very complex decision tree, very big decision tree, and each node has certain rule, your business team might not be able to use the full kind of value of the decision tree. It has to remain in a certain limit. Second thing, when you use this lot of data. Here only I think 9,000 data points, right? If you have million of data points, it will take a long time to run, right? To create a big tree. So that sometimes you have to take into those into considerations also. So with that, let me run this. So only thing what I've changed here, number of leaps, minimum leaps in a node, and how much maximum depth of that decision tree. Then I have two more. Okay, there are two things which I think you might have taken in machine learning, right? So there are two different techniques. One is known as gradient boosting and bagging. Can anybody tell me what is the difference between them? So, anyone? What do you mean by bagging and boosting, gradient boosting? So if it is not covered in machine learning, I hope that will be covered soon. But simply if I want to understand what is a gradient boosting and a bagging model, right? Boosting means I create a decision tree, right? Then based on the error, how much error I'm getting on the decision tree, I create another decision tree with the, see, I do not have new data set. I have how much? 9,400 or 9,500 data points. Out of that, half of them I'm using for the training data, right? So that 4,800 or 4,600 data points I have. With that, I first create a model decision tree using different predictors, different sample of data. Then based on the decision tree which I've created, the error what I'm getting, I create another decision tree, taking another set of variables, another set of. So it is basically you are taking multiple decision trees sequentially, one by one. So next, so the always the next decision tree is better than the previous version. Then whatever error your second decision tree is making, you are trying to minimize in your third decision tree. But using the same set of observations, whatever that 4,000 data points you have 4,800, using that same set of observations, you are trying to build your model one over another, right? So that is where it is gradient boosting. Boosting means step by step. You are moving step by step to your better model. Bagging is when you parallelly create multiple decision tree, right? Let's say whatever data sets I have. So I created one decision tree with certain number of predictors with certain number of classification variables, another decision tree with certain number of predictors, certain other type of classification variables. Like that, I create, let's say 10, 50 or 100 different decision tree, right? Then if I take that average of that, so that is a bagging model, BAGGING, right? This is a boosting model. So bagging model is parallelly you create decision trees, take an average. Boosting model is or gradient boosting. Again, there are different type of boosting model. So gradient boosting is one type of boosting model where you are creating your decision trees in a sequence, one above another, right? Then out of those bagging model, right? One model is known as random forest, right? Again, in random forest, we are creating multiple decision trees. So the theory or the like kind of slides I have mentioned, what is a random forest, what is gradient boosting. So in random forest, each part of bagging like method, but only difference is that in random forest, you are not always taking the same number of predictors. You are reducing number of predictors. Otherwise, what will happen? You are creating a bagging model, you are creating a decision tree, another decision tree will be almost similar to that. So you are creating a lot of repetitions, right? In random forest, what happens, you are trying to removing that repetitions by constraining number of variables you are considering for a decision tree. So that is again, there is a equation is there, square root of number of predictors for any kind of decision tree you are creating. Let's say I have 16 predictors or 20 predictors in a initial number of variables. In a random forest, whenever I'm creating a model, I'll try to use square root of 20. So around 4, between 4 to 5, that means 4. So anytime I'm creating a decision tree using random forest model. I'll try to use only 4 predictors. Then another model using 4 predictors. Like that, I'll keep continuing that. Then again, it is because it is a part of bagging. It is kind of a subset of bagging method. I'm taking a average of decision tree to minimize my error, right? So bagging means create multiple decision trees, take an average of that. Boosting means create multiple decision trees one after another. So try to minimize the error of your previous decision tree, right? So this is gradient boosting, which you can again get from that same model tab. Random forest is not available in the model tab, right? So if you click here HPDM, so HPDM is high performance data mining methods. If you click here, so you'll get HP forest here, right? So again repeating, your gradient boosting, you can find it in the model tab. Same thing like you find in your decision tree. Forest, random forest model will not be available in your model tab. You have to click on high performance TM data mining HPDM, go to HP forest, drag it here. So that is your fourth model. Okay. So because this is a classification method, right? I can still use something called logistics regression, right? Which I'll go back to model regression. Rename. This is my logistics regression, right? LR. So these are my 5 models. Now I have to compare them, right? I'll go to SAS. There is something called model comparison, right? Before that, let me run individual all of them in case there is any issue. So remember the steps: sample, explore, modify, model, and assess, right? Any data mining method go through these steps, right? Sampling of data, then exploring of data, data exploration, feature engineering, then modification, right? Transformation of data, then modeling of data, then assessing the models, how your model works. So any questions, any doubt before this all the models run? So if you go to regression automatically, because we have taken a binary variable as our target B, whether somebody is gifting or not, right? Yes or no, right? Automatically logistics regression is selected, right? In case it is not selected, again you have to change it to logistics regression. So automatically if I go here, logistics regression is already selected. So once it is done, just link this to model assess tab, model comparison. Okay. So now if you see, we have step by step created a complete 5 models and we are going to compare them. We started out the raw data, then we went to the replacement, right? So we wanted to replace whichever values are outliers, then created a data partition, right? Then out of data partition, we created, so this control point will be from the utility menu, right? If you click on this utility, so that will be control point. Because we are creating multiple models, it will be easier for us to compare that. Then we started with the interactive decision tree, then a pruned decision tree, then gradient boosting tree, GBT, then random forest, high performance forest, then logistics regression, right? Then finally, we are going to compare all these 5 models. So if I click on the results, go to result section, it is taking some time to load. Yeah. Share that screen. Okay. So this is the result I have got for your project, which I have given similar kind of results you'll get, but it is not only copy paste this. The idea is you are able to compare them, right? If I go here, so look into the cumulative lift chart, look into the, so each of these you should be able to compare and say that, okay, why this model is working better, right? Lift chart, gain chart, right? So different prune model, full decision tree, prune decision tree, random forest, gradient boosting tree, logistics regression, which model is performing better, which is not performing better. So all these things you should be able to write in your report. So if you go here in the view part, model, there is something called statistics comparison. Already here in the field statistics given that. Right? So, so some of the important statistics like we have discussed, like misclassification rate, right? So clip, if I look into the lip part, cumulative lip part, right? So this model, which is gradient boosting, is giving me a 38% in comparison to, if base model is 1, this is 1.38. So 38% more, 1.38 times more, right? Then this is 3.2. That is what our prune tree is giving 1.35. Random forest is giving very good for 1.43%, right? Generally, the like normal kind of thumb up rule is gradient boosting outperforms random forest than any other bagging model, followed by the your prune decision tree or full decision tree. Most of the times, if you see your gradient boosting, because it is sequentially building model, right? But here, if you see in this particular case, if I take my cumulative lift as my business objective, right? Your random forest, actually high performance data mining random forest is working better. If you see your full tree is very low, 1.11. Last one is your logistics regression, which has a lift of 1.33. Similarly, misclassification rate. So your boosting model has 42, which is a huge, right? 44, 42, 43, 47. Logistic regression is the highest, almost 50%, 47% is highest classification. So decision tree, that is again one problem. It works well for the training data set, performs poor in the testing data set, right? So like this, you have to compare this, say that, okay, why it is working fine, why it is not working fine. And then what else? Then this is the chart, the lift chart, keep gain chart I have shown you. Just a moment. This, okay. No. So I accidentally closed it. So like this, you'll get this output table also, right? So here also you can take these statistics, right, and try to compare among different models, right? So like using different parameters, using different assessment criteria, which model is outperforming the which other model. In some cases and most of the cases, you'll find that gradient boosting is the best model, but that should come from your analysis. That should you should have some values to show that for you, right? So this is about your different type of decision tree models. So same thing you run it for your project. The data set I have given you, it would have been uploaded by now. Put that into your SAS studio, take that, create a library like you did for your earlier classes. Run these 4 decision trees, full decision tree, pruning decision tree, gradient boosting tree, and random forest, then one logistics regression. Then compare all those 4 models, right? Whichever model you will suggest to your business. So that is again similar data set, donation data set. You can use the same steps what we did here, right? Any questions on this? Again, the same thing we are comparing here, right? Leaped gain. Then there are other statistics which you have not discussed, but at least those uh, 4 criteria, right? Your misclassification rate, average square error, your leaped gain, confusion matrix. Those are the things at least you should be able to compare, right? Gini index, I guess it will be there. Gini and entropy for the model parameter selection. That also you should be able to select. Here, if I go here, okay, that is there in the interactive, right? So that also you have to explain, right? When you create that interactive decision tree, which are the values have larger log p value, how it is, how which on which basis the model is selecting. So basically, most of the times your model will be selecting the variable, independent variable based upon your minus log chi-square p-value, right? So smaller the p-value, higher will be the minus log p-value. So based on the highest value, it will be selecting that parameter, right? So that also you can explain when you are creating that interactive decision tree, right? So that's about your, so these are anyhow you can get it here also. Classification. So how much you are able to correctly full decision tree, wrong decision tree, GPT, how much you are able to correctly classify. HP forest, logistics regression. Okay. So any questions, any doubt up to this point? So I've given around 3 weeks of time to complete your project. It's not take more than 1 hour or 1.5 hour. It might take you half an hour or 1 hour to write the kind of what you understand from the charts or what you understand from the numbers. But the main task of creating the model should not take you more than half an hour or 1 hour, right? Any last question before we close? Okay, so if not, that's all for today. So we have, I think, 3 or 4 sessions left in next month, right? So we are going to complete few things. So we'll discuss clustering, we'll discuss market basket analysis. Then I'll show you how to use SAS to do a credit scoring, right? Like your all of us, those of us who are using credit cards, right? Or our education loan, banking loan, right? We'll always have this credit score assigned. 600, 650, 700, 800. Like how do banks calculate that, right? If I have a different information about that customer, right? How to calculate that number, right? So SAS has a inbuilt feature where you can use that to credit scoring, give a credit score to a customer or a respondent. So we'll use that. So these are the three important topics, and if time permits, we'll get into the neural networks that we have not discussed, but at least clustering, market basket analysis, and credit scoring model that we are going to complete in next three sessions. So that's all for today.
Sir, are we going to have presentation on the project that you have given?
No, I don't think we'll have time because I think I was just calculating today how many days, how many sessions. We have, I think, four sessions, 4th April, 11th, 18th, 25th. So we might not get time for a presentation. So that will be a Word document or PDF document which you need to submit.
And sir, after correcting the assignments, can you please upload the marks also?
Assignment for the whichever has given last two classes.
Yes, sir. Yes, last 4 classes we do not have any Excel to see as if.
No, I have already given you quiz marks and your last first two assignment. So I had said that Google, wherever your attendance, I keep updating. So in
Yes,
the
I
same.
will share them. We have the link.
Yeah,
Okay,
I had said in the beginning, just check that whether you have that access to that. Only thing I have not uploaded the last two class assignment. Otherwise,
Okay,
the
sir.
first two class assignment and quiz marks are there already. So and by within next 2 days, I'll upload marks for this last two class assignment.
Sir, are you given a look on those early joining assignments?
Early joining, no, I have not checked up to this point of time.
Okay, sir. Thanks.
But do not submit it late because I'll go by when who is submitting. That late submission will be showing there. So I have not checked. That doesn't mean you will be submitting late. So have you submitted? I think you are giving.
Yes.
Okay. Okay, I think you have April 15th is the last assignment, right? Assignment number 4. That is the deadline. And for your project, I guess 18th is the 18th or 17th is the last date before you complete upload your project. So hopefully by that time we'll be completing another 2 class assignment, and your quiz will happen on the last class, I think on 25th April, quiz number 3. Okay, chalo, take care. We'll meet next class. Discuss, I think, clustering that time. Chalo, bye bye.
Thank you, sir.